Hello everyone, introduction part 2. We will continue with the slabs. First of all, we show the plan of this project. This is the general plan. We use it in the next section to import it into ETABS software. These are the shop drawing of waffle slab, ribbed slab, solid slab and flat slab. We return to the presentation and we begin with story 1, waffle slab type 1. We have know that we have two types of waffle slab type 1 and waffle slab type 2. And story 1 we have waffle slab type 1. First of all, we must know that waffle slab is a two-way slab. That means the slab have ribs and two direction. We show that ribs direction Y and the ribs and direction X. So this thing we call it two-way slab. Waffle slab. Also, the advantage of waffle slab is that the waffle slab can bear a high live load. And story 1 we have a parking. So for this thing we use waffle slab. Also waffle slab for long span between columns. So these two things we choose to use waffle slab and story 1. Now we want to determine the overall section of this waffle slab and story 1 to modeling it into this ETABS software and save, and then check it if it's sufficient or we more decrease or increase this section. We determine this section to be more near the required section to decrease the try and error time. So we must, according to ACI code, we determine this section. How we determine this section? We go through slide 11. First of all, we must know that waffle slab is a two-way slab. We use waffle slab when we have long spans and high live load. Spacing between ribs above 1 meter and below 2 meter. What is this? We go through the TOCAD and to waffle slab. We note that the shop drawing is this shop drawing is for waffle slab type 1. What's mean that the spacing between ribs is above 1 meter and below 1 meter. We show this section of waffle slab. This is the spacing between ribs from the mid of this spacing, from the mid of this spacing to the mid of this spacing is between 1 meter to 2 meter. This when S is between 1 meter and 2 meter, we call waffle slab type 1. When S is between 0 and 1 meter, we call waffle slab type 2. And story 1 we have waffle slab type 1, so S between 1 meter and 2 meter. We show here that the spacing between the mid spacing, we show that the spacing between the ribs and Y direction is here is 1.6 and X direction, X ribs is equal to 1.6 also. So this waffle slab is a waffle slab type 1. We continue in the presentation. We must know that when using ETABS software, always we put dead load for waffle slab 3.5 kN per meter square. This load is excluding the self weight because ETABS calculate the self weight automatically. Also we have live load equal 5 kN per meter square because we have parking. This load we get it from the table of live load from ACI code. This table help us to determine the section of the waffle slab type 1. We show that we have anterior without drop, anterior with drop, exterior without drop, exterior with drop. Also we have here here spacing above 1 meter. to tell us that this table is for waffle slab type 1, not for waffle slab type 2. So spacing above 1 meter, we have L over 22, L over 24, L over 20, L over 22. First of all, what is interior and exterior, with drop or without drop? We go through, we want to define this parameter. What are these parameters? First of all, we call this part of the slab is a panel. We call it panel. This is a panel, and this is a panel. So we divide the waffle slab into story 1 to a panels. So we show that this is a panel, and this is another panel, etc. So we look now to this panel. We show that this panel is an exterior panel because it has two exterior edge. Also, this panel is an exterior panel. So all these panel are exterior panel. Also, these panel are exterior panels. The same for this panel and this panel. But this panel here, we show that these 4 panels are an interior panels because all the edge of this panel are interior and the slab. So we return to the table. We show here that we have 4 interior panel without drop, okay, and interior panel without drop, and with drop for the beams. If we have to use drop beam, we must use L over 24. If we don't need to use drop beam for interior panel, we use L over 22. L is L average. L average equal Lx plus Ly over. So for example, for this interior panel, Lx equals 610 centimeter and Ly equals 710 meter. And this project we need to use hidden beams. So we are in this case, we are in the first case, interior panel without drop. So these interior panels, okay, these 4 interior panels they are in this case L over 22. LL and L equal to Lx plus Ly and over 2. For exterior panel, we want to use also without drop. So we are in this case L over 20. Okay, we must check each panel and take the maximum edge to modeling it into the ETABS software. So we return to the presentation. We show here that the edge of the slab, the maximum edge of the slab equal to we take it from this panel. Ly equals 710 plus Lx equal 548 over 2 times 0.5 over 20. Why over 20? Because exterior without drop, and this panel is an exterior panel without drop. We can check other panel, but this panel gives the maximum thickness for the slab, waffle slab. So we summarize the calculation for only this panel. So the edge of the slab equals 31.45 centimeter, approximate 32 centimeter. We need to use hidden beams. So edge of slab equal edge of beams. So we need to calculate the minimum thickness of the beams and compare it with the thickness of the slab. If the thickness of the slab below the thickness of the beams, we want to take for the edge of the beam to the slab. So from this table we can calculate the thickness of the beam. We have this parameter, simply 1 and 2 and cantilever and the drop and hidden. We need to use to calculate the thickness of hidden beam. So we want to look here. Simply supported case is for this beam. We show that, and the AutoCAD we show it's not continued above and not continued below. One end continuous, we show that this beam is an one end continuous because it is continued with one edge, and another edge is not continued. Two end continuous like this beam because it is continued and the two edge and right and left. Cantilever, it's not our case. We don't have any cantilever beam in this plane. So we want to calculate the maximum thickness of hidden beam. It given this maximum is if we look to this beam B11, it's an one end continued. It's an one end beams. This beam is an one end beam, so the thickness of this beam is equal to 695 over 18.5 because one end continuous and head beam equal to 38. So the edge of slab 38 centimeter is greater than 32, and we need to use hidden beam. So edge of slab equal edge of beam. So we take edge of slab equal edge of beams equal 38 centimeter. If the edge of the beams equal, for example, 30 centimeter, we take edge the slab is the critical, and we take edge the slab equal edge to beams, edge of beam equal 32. But here we have edge of beam equal greater than the edge of slab, so we take the critical section is for beams. So we take edge of slab equal edge of beams equal 38 centimeter. S1 and S2 is the spacing between the ribs because it is an waffle slab type 1, so the spacing of ribs is above the 1 meter, and between 1 meter and 2 meter equal 1.6 meter. R is the width of the ribs. If we look here, it is the width of the ribs. If we look here, R equal the width of the ribs of each ribs, and the two direction x and y equal to 20 centimeter. We show here 20 centimeter. These are a constant section. We can use it always, but we must calculate the thickness of the slab. These parameters or this section are critical for and standard for waffle slab. So the beams of waffle, we assume that the hidden beams are with width equal to 100, and for depth as we calculate before equal to 38 centimeter, and the overall the thickness of the slab equals 38 centimeter. Thank you for watching. We will continue at the next section the calculation of the waffle slab type 2. Thank you.